Well, we can talk about substances and we can observe and measure them, and we've been doing some of those things. But now we're going to think about the smallest particles of those substances. We're going to think about atoms. And by thinking about what atoms are made of and what the insides of atoms are going through, we might have an idea to kind of understand why atoms and the compounds that they make up do the kinds of things that they do. So we're going to talk a little bit about what's going on inside of atoms. So in this video, we're really going to concentrate on the submicroscopic, the atoms. Atoms are too small to see, even with a microscope. And we need to keep track of what's going on inside of them, so we're going to talk about how we do that, what kind of symbols, what kind of math we use, and so on and so forth. Now, some of this is going to be review. You've heard about the basic particles that make up atoms: protons, neutrons, and electrons. So we're going to review those things using a grid that looks like this one. It's a 4x4 grid. In the first column are different subatomic particles. These are the major subatomic particles. It turns out that atoms, protons, neutrons, and electrons are also made of even smaller particles. But what we're concerned with in our course is just these three types of subatomic particles. And we're going to compare them based on some of their characteristics. And we're going to consider their charge, how much mass they have, and also where in the atom they're located. So let's start with the property of charge. Protons have a +1 charge. So this is the kind of charge that maybe we associate with electricity. And electrons have the opposite charge of a proton. They have a -1, 1 unit of negative charge. Protons have 1 unit of positive charge. That's a very important characteristic of these particles because it's the charges of the particles that keep the electrons in the area of the protons, and that's what allows the atom to exist, really, the fact that the electrons are attracted to the protons. Now, the neutrons don't have any charge, and you might think, well, you know, what do they matter? But they do have a function, but they don't have any charge. So let's compare them for mass. Protons, neutrons, and electrons are extremely small. Atoms are small, and these things are smaller than atoms. So there's a special unit of measure we use when we're discussing the mass of these very small particles. And it's called the atomic mass unit, the AMU. And a proton has a mass of 1 AMU. It turns out that a neutron also has a mass of 1 AMU. Now, these two particles are not exactly precisely the same mass, but for our purposes, close enough. So we're going to call them each 1 AMU. Now, electrons do have mass, but they're much smaller than protons and neutrons. And so for our purposes, we can say that electrons approximately have 0 mass. That is an approximation, but compared to protons and neutrons, electrons have hardly any mass at all. All right, where are these things located? Well, you may have heard about this before. Protons are in the nucleus of an atom. The neutrons are also in the nucleus of an atom. Let's look at these last two columns. Protons and neutrons are in the nucleus, and they each have some mass. Electrons are going to be, we're going to find that they're outside of the nucleus, so it looks like almost all of the mass of an atom is in its nucleus. So that's an interesting characteristic of atoms also. We'll learn much more about where exactly electrons are located, but for now it's enough for us to say that they're not in the nucleus. They're outside of the nucleus. They're busy doing other things, but they're not in the nucleus with the protons and the neutrons. So there we are. There's our summary. Protons, neutrons, and electrons are three major subatomic particles. Here's some characteristics, how they compare with one another. All right, how are we going to find out if these atoms are too small to see, and if the protons, neutrons, and electrons are even smaller than that? How do we know how many there are, or where they are, or what they're doing? Well, we can look some of those things up. They've been established by scientists over a period of years. So the number of protons in an atom is the atomic number of the element. Let's think about the kind of information we might find on the periodic table. Here's an example of the square that we might see on the periodic table. This is, of course, for the element sodium with the symbol Na. And typically on a periodic table, we might see a number like this one, a whole number. And we also might see a number like this with a decimal in it, and several numbers after the decimal place. So it's this number here, the whole number, that is the atomic number of the element we're talking about. And the atomic number is the number of protons in an atom of this element. So every sodium atom has 11 protons. And every atom that has 11 protons is a sodium atom. This is a unique number of protons for a sodium atom. So it's really the number of protons that defines what kind of an atom we have. Let's think about another example here. Here's copper. Copper has an atomic number of 29. That means every copper atom, every single one, has 29 protons in it. All right, let's think a little bit about electrons. Now, electrons in a neutral atom, the number of electrons is the same as the number of protons, but we want to guard against saying that the atomic number is the number of electrons, because the number of electrons can change a little bit. Electrons, because they're not in the center of the atom, they're on the outer edges, at least some of them are, some of those electrons can come and go from an atom. So an atom can turn, a neutral atom that is, can turn into what we call an ion by gaining or losing an electron, or electrons, one or more electrons. So an ion, here's that word right here, ion, is an atom or a group of atoms with a charge. And how does it get a charge? It gets a charge by either gaining or losing electrons. Okay? So the atomic number is the number of protons. In a neutral atom, that's the same as the number of electrons, but in an ion, the number of electrons does not equal the number of protons. Okay? So we can figure out something about the number of electrons if we think about the charge of an ion, and we'll do that at some point. All right, let's think about the number of neutrons now. What can we tell about neutrons? Well, the number of neutrons isn't on the periodic table, and it's not easy to figure out. And the reason for that is because not all atoms of an element have the same number of neutrons. So atoms have different isotopes, and an isotope or isotopes of atoms are the isotopes of elements, let's put it that way. Isotopes of elements are atoms with different numbers of neutrons. So how are we going to know how many neutrons are in an atom? Well, we can estimate it if we take the atomic number of an element and subtract it from the average atomic mass. So here's our information for sodium. Here's the average atomic mass of a sodium atom. One sodium atom weighs 22.98977 AMUs. If we take away the atomic number, 11, we end up with 11.9. Well, that can't be the number of neutrons. We can't have part of a neutron. But it does tell us that a typical sodium atom has approximately 12 neutrons in it, about 12 neutrons in it. Okay? So, if we want to know exactly the number of neutrons in an atom, somebody either has to tell us that, or has to measure it using expensive equipment, or we have to know the mass number. So the mass number is a number for a particular atom, a specific atom. The mass number is the number for a specific atom, and it's the total of the number of protons plus the neutrons in that atom. The mass number is not on the periodic table because different atoms of an element have different mass numbers. These little equations at the bottom will help us summarize the idea of mass number. Mass number equals the number of protons in an atom plus the number of neutrons in that same atom. The mass number equals the atomic number plus the number of neutrons in that atom. Okay? So we can use the mass number. If we have a mass number for an atom, we can use it to figure out the number of neutrons in that atom. All right, let's summarize what we've just heard, some of which is already reviewed. We know that the basic subatomic particles are protons, neutrons, and electrons. What you should have gotten from this video is the charge of a proton and a neutron and an electron. You should also have gotten the mass of a proton, a mass of a neutron, mass of an electron. Intermitting here. We should also have figured out that protons and neutrons, where they're located within the atom. Ions form when electrons come to an atom or leave an atom. The atomic number, something found on the periodic table, tells us about the number of protons in an atom. The average atomic mass of an atom is also located on the periodic table. That tells us approximately the number of protons plus neutrons. The mass number is a number that we might be able to get for a specific atom, one specific atom, which tells us the exact number of protons and neutrons in that atom. And finally, we heard about the word isotope. Not all atoms of the same element are the same, because sometimes they have different numbers of neutrons. That's it. Talk to you later.